Within the topic of the theorem of Pythagoras, we are going to focus on the angles of a triangle. In the previous lesson, we focused on the sides of a triangle. Firstly, in any triangle, the longest side is opposite the biggest angle, and the shortest side is opposite the smallest angle. So there's a direct relationship between the size of an angle and the opposite side length. In a right angle triangle, we also know that the largest angle is 90 degrees, so therefore the longest side is always opposite the right angle. We have shown it, we have used it in the previous lesson, in fact, many times to determine the hypotenuse. So now in exercise 15.4, question 1, according to triangle ABC has AB equals 7 meter, just change that to centimeter, it's an error in the book. So we have AC equals 8 centimeter, and then we have AB equals 7 centimeter, and then BC 8 centimeter. So now the first question, or first sub-question A, is whether A, B, or C is the biggest angle. We need to justify our answer. Now, the thing is, opposite the shortest side, we have the smallest angle. So we know C is the smallest angle. But now, since opposite B we have 8 and opposite A we have 8, which is bigger than 7, A and B must be bigger than C. And since they are opposite them, we have the same side lengths, we know that angle A and angle B is the same. So for A, the answer will be A and B are the biggest angles. Reason is largest angles opposite longest sides. So therefore we have two angles that are the same and the largest. So now that we know that, we need to classify the triangle fully. Now, what we need to do here is we need to take consideration that we have two sides that are the same length. So therefore, they are, or this is an isosceles triangle. Now the thing is, we have to compare the longest side squared to the sum of the two shortest sides squared. So now the problem is we have two longest sides squared, two longest sides. Let's just use one of them. So we need to compare 8 squared, which is 64, against 8 squared plus 7 squared, which is 64 plus 49. So it's the same as 130. So since the longest side squared is smaller than the sum of the two shorter side squared, we know that this must be an acute angle triangle. See, if the longest side squared was equal to the sum of the two shorter sides squared, we would know it is a 90-degree angle, because that would be what Pythagoras in fact says. Pythagoras says this in a 90-degree or a right angle triangle, the longest side squared, the hypotenuse squared, equals the sum of the other two sides squared. So the fact that we have 64 versus 113 indicates to us that this cannot be a right angle triangle. And then furthermore, secondly, the fact that the longest side squared is smaller than the sum of the others indicate to us that this must be an acute angled isosceles triangle. So if in fact the longest side squared was larger than the sum of the two other sides squared, it would have been an obtuse angled isosceles triangle. But in this particular case, since it's smaller, it must be an acute angled one. So with that said, let's focus on number 2. Now we have triangle DEF as D is 7, EF 7, and DF is 7 square root 2. Let's see, what is the longest side? We know we have a tie here. What is the square root of 2? Is it something bigger than 1? Yes, it will be something bigger than 1. Even the square root of 1 is 1. So the square root of 2 must be bigger than something 1. If you take 7 and multiply it by something bigger than 1, you will get an answer bigger than 7. So DF must therefore be the longest side. It is in surd form as 7 square root 2. And then the other two sides are 7 respectively. Okay, so now the question is, which angle is biggest? Well, the angle, okay, this must be E therefore, the angle opposite the longest side. So this angle E is the biggest. So angle E is the biggest as it is opposite the longest side. Next we have to fully classify the triangle. So now we need to say which kind of triangle it is. So what we have to do is we have to use what we know of Pythagoras. It says so let's first test if it's a 90-degree one. If it's a 90-degree triangle, then, or a right angle triangle, then the longest side squared, which is 7 square root 2 squared, we have to compare to the sum of the two shorter ones, and if they are equal, it would be a 90-degree or right angled triangle. So if we square, we may separate, so it's the same as saying 7 squared times square root 2 squared, which is the same as 49. We know square and square root cancel, so it's 49 times 2, which is 98. Okay, so now let's look at if we square the two shorter sides. 7 squared plus 7 squared is the same as 49 plus 49. And 49 plus 49 is 98. Voila. So therefore we can say E squared is equal to, well, small letter E squared. Remember, opposite the big capital we have small letter, opposite big F we have small f, opposite big D or capital D we have small d. So E squared is in fact D squared plus F squared. And so therefore, in fact, we have a 90-degree angle for angle E, So therefore this must be a right-angled isosceles triangle. Okay, so right-angled we just showed via the what we refer to as the converse of the theorem of Pythagoras. Converse means in a sense opposite. The theorem of Pythagoras says in a 90-degree triangle, the longer side square equals the sum of the two shorter sides. The converse theorem says if the longer side squared equals the sum of the two shorter sides squared, it has to be a 90-degree or right-angle triangle. That is what the converse of the theorem of Pythagoras says. So right-angled isosceles triangle due to the converse of Pythagoras. The isosceles we know, we have DE equals EF. DE equals EF. We have two sides that's the same, that's why it's isosceles, right-angled due to the converse of the theorem of Pythagoras. Now we need to calculate with reason the size of angle D. Well, we know a triangle has 180 degrees, so we can in fact, and we also know since side EF is equal to side DE, since this and this side is the same length, we know that the angles opposite this side and the angle opposite that side have the same size. So we can say it's in fact angle X and angle X. We don't know yet what the size is, but we know they are the same. So therefore we can make a statement that X plus 90 degrees plus X equals 180 degrees. Reason angle sum of triangle. We know it's 180 degrees. Now we can solve. We have 2x's equals 180. Swim the 90 across. So it's 180 degrees minus 90 degrees. So therefore, in fact, we have 2x equals 90 degrees. Divide both sides by 2, so x is in fact 45 degrees. Okay, so now let's focus on number 3. We have to classify triangle PQR if P is 5, Q is 8, and R is 9. So what's the longest side? 9. We have to classify, we have to compare the longest side squared to the sum of the squares of the two shorter sides. So we have 25 plus 64, 5 squared 25, 8 squared 64, which is 89. You see it's not the same, so it can't be a 90-degree angle triangle. 81 is smaller than 89, so therefore it must be an acute angle triangle. Since all the sides are different lengths, it has to be a scalene. So PQR is an acute angled scalene triangle. Since all sides unequal, and 9 squared smaller than 5 squared plus 8 squared. So you try number B. Let's see how you do with number B. For those that are a bit uncertain, first hint, take the longest side, square it. Compare that to the two shorter sides squared added together. So the longest side squared is 12 squared, which is 144. Two shorter sides, we have 6 squared plus 9 squared. 6 squared, 36. 9 squared, 81. 36 plus 81, 117. They are not equal, it can't be 90 degrees. The largest side squared is bigger, so it must be an obtuse. So it's an obtuse angled, all the sides different lengths, scalene therefore triangle. So the reasoning, obtuse because 12 squared greater than 6 squared plus 9 squared, and all sides unequal. That's why it's scalene. So for homework, if you can try the rest of number 3, the remaining ones of number 3.